Pratibha College of Commerce and Computer Studies, Chinswad, Pune organizes a course on business mathematics. This course BBA, BBA-CA, BFT and also the students who are appearing for various entrance examinations as well as the students who are appearing for the competitive examinations like MPSC, UPSC, banking, etc. The objective of this course is that the student should be able to understand the mathematical formulae, basic concepts, mathematical expressions in the business mathematics, and they should be able to apply this knowledge into their daily life as well as in the banking, commerce, finance, management, etc. Hello all, I am Dr. Rajeshree Nanaware, Program Coordinator of BSc Regular and Head Department of Mathematics. I am going to present the first module of this course, which is ratio, proportion and percentage. Here you can see the diagrammatic representation between fraction, ratio, proportion and percentage. A fraction is a relationship between part to total. Part to whole or part to total. Here I have given the representation of the number 3 by 4 or 3:4. Ratio represent a quantitative relationship between the quantities which are of the same type. So ratio can be represented in the fraction form as 3 by 4 and in the ratio form as in the standard format as 3:4. Talking about a proportion, it is simply a statement in which two ratios are equal, and percentage means each hundredth. So it is a special kind of ratio where the denominator is 100. So I have given representation of this number 3 by 4 in the proportion as 0.75 and in the percentage as 75%. So here in this module, we'll see ratio, proportion and percentage. In the ratio, we'll see continued ratio, inverse ratio. In the proportion, we'll see continued proportion, direct proportion and inverse proportion. And lastly, we'll see about percentage. So let us begin with the first concept, which is ratio. We use ratio to do the comparison between two quantities. For example, marks in the examination. So here I will give you one example. Suppose in a family there are two children, namely Ajay and Rakesh. Suppose Ajay got 60 marks out of 80 and Rakesh got 30 marks out of 50. Then how do we compare the performances of these two children? So by just taking the ratio of the marks obtained divided by total marks. So this is the ratio of first one, which is Ajay. So I can represent in the ratio form as 60 by 80. So here we'll get here the ratio as 3:4. And the secondly, here we can simply get the ratio as 3 by 5. So here we can easily compare their performances. Here we can see 3 by 4 is greater than 3 by 5. So performance of Ajay is better than performance of Rakesh. So there are different examples where we use the ratio here. Time to reach the destination, ages of family members, scores in cricket match, incomes of persons, sales of different goods, etc. Even whenever we invest the money into the bank, we compare the interest rate per annum. Here is the note. Ratio is used only when the unit of the measurement of two quantities is same. Now let us see the definition of ratio. If x and y are quantities of similar type with the same units, then the quotient x upon y is called the ratio of x to y. Let us see the notation. The ratio of x to y is denoted by x is to y. Ratio has no any unit. In the ratio x is to y, the variable x is called antecedent and the variable y is called consequent. Next note is ratio remains unchanged if we multiply or divide the ratio by the same number. So this is about some important note about the ratio. Let us see some examples based on the concept ratio. So we'll start with the first example. Ratio of two numbers is 3 is to 5 and their sum is 232. Find the numbers. So here is the solution. The ratio given is 3 is to 5 and their sum is 232. So let us assume that the common ratio be x. So by using the given ratio, the given numbers become 3x and 5x respectively. And what is given? Their sum is 232. So here we add these numbers 3x and 5x. So 3x plus 5x is equals to 232. So adding this, we will get 8x is equals to 232, and if we will divide by 8, we will get x is equals to 29. So here our given numbers are 3x and 5x. So we will just substitute here the value of x, which is 29. So 3x will get as 3 into 29, which is 87. And here the second number, which is 5x. So we will again substitute x equal to 29 here. So 5x is equals to 5 into 29, which is 145. So here is the answer. The required numbers are 87 and 145. So this is how we can find the numbers where the ratio is given as well as their sum is given. Now we will see the second example. Here ratio of two numbers is 4 is to 7 and the bigger number is 147. Find the smaller number. So here the ratio and the bigger number is provided. Okay. So let the common ratio be x. So similarly, as like the ratio is 4 is to 7, the given numbers becomes 4x and 7x respectively. And bigger number is 147. So see here, out of these two numbers, 4x and 7x, here 7x is the bigger or the greater number, and it is given that the bigger number is 147. So what we will do is, we will equate 7x to 147. Okay, so here dividing by 7, we will get the value of x as 21. So here we have here the smaller number is 4x and bigger number is 7x. So we have to find the smaller one. So here the smaller number is 4x. So here 4 into 21. Okay, so it is equals to 84. So here we have got the value of the smaller number as 84. So now we will see the next concept, which is continued ratio. So let us begin with the definition. Three quantities are said to be in the continued ratio if the ratio of the first term and the second term is equal to the ratio of the second term and third term. So suppose here the three quantities are x, y and z. Okay, so the three quantities x, y and z are said to be in the continued proportion or continued ratio if x is to y, which is equals to y is to z. So here we will write here in the form of fraction here x upon y is equals to y upon z. So here y is called the mean proportion to x and y, because here it will do the cross multiplication here, y square is equals to x into z. We will get here y square is equals to x into z. So here we have this y, it is called the mean proportion to x and y. Again, we will extend this concept of the continued ratio to the four quantities. So here, four quantities are said to be in the continued ratio if the ratio of the first term and second term be equal to the ratio of the second term and third term be equal to the ratio of the third and fourth term. So now see, if x, y, z and w, these are the four quantities, and these four quantities are such that x is to y, which is equals to y is to z, which is equals to z is to w. That is x upon y, which is equals to y upon z, which is equals to z upon w. Okay, then they are said to be in the continued proportion. So this is about the continued ratio of the four quantities. Now we'll see the examples based on this continued ratio. Here, if x is to y is 4 is to 7 and y is to z is equals to 9 is to 5, then find the value of x is to z. So here we'll write in the fraction form this x upon y is 4 by 7, and here x upon z it is equals to 9 upon 5. Okay. So actually we have to find x is to z, that is x upon z. So how we can get it? Just if we divide this x upon y and z upon y. So here we have the value of y upon z, which is 9 by 5. So whenever we take this quotient, we will get x upon y, which is equals to into y upon z. Okay, so it is equals to, here x upon y is 4 by 7. And here y upon z, which is 9 by 5. So just if we multiply this, we'll get here 36 upon 35. So this is how we can find out this x is to z. Now let us see the next example. The sum of the present ages of 3 persons is 66 years. 5 years ago, their ages were in the ratio 4 is to 6 is to 7. Find their present ages. So here what is given? Sum of the present ages of 3 persons, which is 66 years, and the ratio of their ages 5 years ago, just 5 years ago is given 4 is to 6 is to 7, and we have to find their present ages. Okay, so let the common ratio be x. Then the ages of 3 persons before 5 years, because whatever is given, the ratio given, it is the ratio of the ages 5 years ago. So the ages of these persons 5 years ago be 4x, 6x and 7x respectively. But we want to find their present ages. So what happens? Their present ages becomes 4x plus 5, 6x plus 5 and 7x plus 5 respectively. And now we can use the information that sum of their present ages is 66 years. So now we'll just add this ages. Okay, 4x plus 5 plus 6x plus 5 plus 7x plus 5, which is 66. So adding the terms of x together, here 4x plus 6x plus 17x. So here we'll get 7x. Here we'll get 17x, and this 5 plus 5 plus 5, 15. So I'll just take this 15 on the RHS by subtracting here 66 minus 15. So here 17x, which is equals to 51. So here dividing by 17, we'll get the value of x as 3. Okay, so here their present ages, which are 4x plus 5, 6x plus 5 and 7x plus 5, we can get these values by substituting the value of x as 3 in this. Okay, so 4x plus 5, which is 4 into 3 plus 5, which is 17 years. Then next is 6x plus 5, so 6 into 3 plus 5, which is 23 years. And last here 7x plus 5, which is 7 into 3 plus 5, so it is 26 years. So here we have got the ages of these persons as 17 years, 23 years and 26 years respectively. Next example is sand and cement are in the ratio 6 is to 5 in a mixture weighing 671 kg. How much sand must be added to the mixture so as to make the ratio 8 is to 5. So the previous ratio of sand and cement is 6 is to 5. Their weight is 671 kg, and we have to find out how much quantity of sand is added to make the mixture ratio of the mixture as 8 is to 5. So let us begin. Okay, so let the common ratio be x. Then the weight of the sand and cement be 6x and 5x respectively. Given is the weight of the mixture is 671. So we'll just add this So 6x plus 5x is 671. So here we'll get this 11x is 671. So dividing by 11 we'll get x is 61. So here as the ratio of sand and cement is 6x and 5x. So here we'll get 6x as 6 into 61, which is 366, and that of cement, which is 5x, so it is 5 into 61, which is 305. So here we have got out of this 671 kg, sand is of 366 kg and cement is of 305 kg. Okay, but next in this we have to find how much of sand is added to make the mixture, or ratio of mixture is 8:5. So here we'll add M. Okay, so the sand added in the mixture is M. We'll assume it is M. So 366 plus M upon whatever is the cement, weight of cement, we'll take it as it is. So 366 plus M upon 305, which is 8:5. So we'll write 855. So now just we have to do the cross multiplication. We'll multiply 5 to this bracket and 8 to 305. So here we'll do the multiplication. So here 5 into this 366 plus m, which is 305 into 8. So here we'll multiply 5 to 366. We get 1830 plus here 5m, which is equals to 2440, okay, 2440. So here 5m, we'll get 5m as, we'll check this on RHS, we'll subtract this. So here we'll get 5m, which is equals to, we'll do the subtraction and we'll get it as 610. Then dividing by 5, we'll get the value of m as 122. So here is the quantity of sand must be added to the mixture is 122 kg so as to make the ratio of the mixture as 8:5. Now the next example, monthly incomes of two employees are in the ratio 3:5. If each receives an increase of rupees 200 in monthly salary, then the new ratio is 13:21. Find their original salaries. So let the common ratio be x. So their original salaries become 3x and 5x respectively. Then here, as each receives an increase of rupees 200 in their monthly salary, therefore after this increase their salary becomes 3x plus 200 rupees and 5x plus 200 rupees. So here the ratio of the salaries, okay, after adding this 200, the new ratio becomes 13:21. So we equate this 3x plus 200 upon 5x plus 200 to 13/21. So again the cross multiplication, we'll do the cross multiplication here. So here 21 into 3x plus 200, which is equals to 13 into 5x plus 200. So here we'll multiply this 21 to the bracket. Here we'll get 36x plus 4200, which is equals to 65x plus here it is 2600. So here we'll get the values of x, terms of x together. So 65x minus 63x, which is equals to here 4200 minus this 2600. So here after doing the subtraction we'll get 2x, which is equals to 1600. So from this we can get the value of x as 800. So here their original salaries are 3x. So 3 into this 800 becomes 2400, and here 5x, so it is 5 into 800, which is 4000. So here their original salaries are 2400 and here 4000 respectively. So this is how we can find the values of their origin. Nextly we will see the examples based on the continuous proportion. So here find m if 5, 10 and m are in the continuous proportion. So here we can compare this with our original definition, that x, y and z are in the continuous proportion. Then we can write here x upon y, which is equals to y upon z. So it is x into z is y square. So here we will represent these numbers as x, y and z. So here we'll get x into z, that is 5 into m, which is equals to 10 square. So Here we'll get 5m is 100. So simply here we'll get m is equals to 20 by dividing by 5. So here we'll get the value of n as 20. Next is inverse ratio. The ratio of the reciprocals of two quantities is called as inverse ratio. Simply we have to just take the reciprocal of the original ratio. So here on the example, the inverse ratio of 3 is to 4 is 4 is to 3, and the inverse ratio of 4 is to 3 is 3 is to 4. Next is the inverse ratio of 2 is to 3 is 3 is to 2, and here the reciprocal of 3 is 1 is to 3. So simply it is same as the inverse ratio. Now the note is the product of the ratio and its inverse is unity. So here you can see, suppose I take the ratio here, 3 by 4, and its inverse ratio is 4 by 3 or 4 is to 3. So here the product of the ratio and its inverse, okay, or inverse ratio. So 3 is to 4 into 4 is to 3. So the product becomes 1. Okay, so simply this quantities get cancelled, and here we'll get the value as unity, that is in fact 1. So this is about the note. Next thing is we'll see the definition of proportion. A proportion is simply a statement that two ratios or fractions are equal. That is, four quantities x, y, z and w are in proportion if x is to y is to z is to w. Here we can represent them as x is to y, which is equals to z is to w. So here we will get x into w, which is equals to y into z. In a proportion, the first and the fourth terms are called extremes, and while the second and the third term are called means. And here you can see here the product of extremes, that is x and w here, that is equals to product of means. Okay, so this is about the definition of proportion. Next is continued proportion. Here simply just like a ratio, we have the concept of continued proportion. If three quantities are such that the ratio of the first to second is equal to the ratio of second to third, then these three quantities are said to be in the continued proportion. Here the middle term is called mean proportional between first and third terms. So here x, y and z are in the continued proportion if x is to y, which is equals to y is to z. So here in this proportion, here y is the mean proportional between x and z. Here the third quantity is called third proportional to the first and the second, and z is the third proportional to x and y. Okay. Nextly, we see the definition of direct proportion. As one variable increases or decreases, then the another variable increases or decreases at the same proportion, then the proportion is called direct proportion. Here the symbol for the direct proportion is this like alpha. Okay, and the notation is if the variables x and y are directly proportional, then we can write x is directly proportional to y. Okay, if x is directly proportional to y, we can write here x is equals to k into y. Here k is called the constant of proportionality. So here is how we can write the symbol of the direct proportion and how we can represent the direct proportion between these two variables, where is k is a constant of. Next to direct proportion, here the next definition is inverse proportion. So it is totally reverse to the direct proportion. So here you can see, as one variable increases or decreases, the another variable decreases or increases at the same proportion, then the proportion is called inverse proportion. So here notation, if two variables x and y are inversely proportional, then we can write x is directly proportional to 1 upon y. So here that is x is directly proportional to 1 upon y. So whenever it is so, x is directly proportional to 1 upon y, we can write here x is equals to k upon y, that is k is equals to x into y. So here again k is the constant of proportionality. So that is about the inverse proportion. Now we'll see the examples based on this direct proportion, inverse proportion. So here, if A is directly proportional to B, A is equals to 4 when B is 6, then find the value of A when B is equals to 27. So given is x is directly proportional to A is directly proportional to B here. So here, whenever A is directly proportional to B, we can write A is equals to K into B, where K is a constant of proportionality. So here, substituting the values of A and B here, A is 4 and B is 6. So here 4 is equals to K into 6. So here we get K is equals to 4 upon 6. So simply we can write this 4 upon 6 as 2 upon 3. So now we have A is equals to 2 by 3 into B. So now let us see, we have to find here A when B is 27. So here if we substitute the value of B as 27, so here we will get 2 by 3 into 27, and here we will get this 2 by 3 into 27, so it is simply 18, 2 into 9, so the value of A is 18. So this is how we can solve the examples based on the data. Now the next example, here a car travels 81 kilometers in 4.5 liters. Then how far will it goes by 20 liters of petrol? So whatever the information is given, that we'll try to write in the tabular form, and we try to understand what is the relationship or which kind of proportion is there in between these quantities. So here the distance is given, okay, 81 kilometers, and here the petrol in liters is given. So first information here, the car travels 81 kilometers in 4.5 liters, and secondly how far it goes by 20 liters. Okay, so here in the second part, the petrol of 20 liters, the quantity is given, and we have to find how far will it go, means distance we have to find, okay, how much distance it will cover by using this 20 liters of petrol. So after writing this in the tabular form, like original value and new value, we'll identify what is the proportion in between this distance and petrol. So here you can easily see that the distance and petrol are directly proportional. Okay, so if the car want to travel the greater distance, it require greater petrol. Okay, more petrol. So likewise, we can see here it is a direct proportional. So here now we'll write this in the ratio format. So here we'll write new value upon original. So here x upon 81 is equals to 20 upon 4.5. So here we have to find the value of x, okay, which is the distance. So x is equals to here 20 upon 4.5 into 81. So if we'll do the calculations here, we'll get the value of x, which is equals to 360 kilometers. So this is how you have to identify the relationship between the quantities and find whatever is the required answer. Next is 75 persons do a piece of work of 12 days or 10 hours. Then how many persons can do the piece of work twice in half days, okay, working 8 hours. So this much information is given. So just like the previous example, we'll try to make the table here. So we'll write these quantities, persons, work, then how many days and how many hours in the tabular form. So whatever is given, we'll write here 75 persons here, one work they are doing, then 12 days and 10 hours. Nextly, we have to see whatever is asked, whatever is given in the second half part. We have to find how many persons does twice work. Then in half days means here 12 days are there, so we can use 6 days, half days here, and 8 hours. So just we have filled the information whatever is given. Now we have to identify the relationship or the proportion. So here we have to find here how many persons. So here we can also write a dash, and here we can write the ratio x upon 75. Okay, And here we can see here if we increase the days or hours, the work will be done in less time. Okay, so here we have to write the proportion as inverse. If we increase the hours or days, then the work will be finished before whatever we are expecting before that time. So here x upon 75, which is equals to 2 upon 1, here 2 upon 1. Then here the inverse proportion is there. So here we have to write 12 upon 6. Then here inverse proportion there. So here 10 upon 8. So here x upon 75 is 2 upon 1 into 12 upon 6 into 10 upon 8. So x upon 75, we will do these calculations and we can see whatever is the right hand side, it is 5. So the value of x, which is equals to 75 into 5, that is 375. So simply here we will get the answer as 375. Now we will see the last point, which is percentage. Here percentage means each 100. It is a special type of ratio in which the denominator is 100. So here we can represent this number 1 by 2 as 0.5, and in the percentage we can represent as 50%. So here firstly on the example x percent is x upon 100, because in the percentage the denominator is 100. Next is 75%. So here 75 upon 100, so it is 3 by 4. 20% of 125. So how we can find out here 20%? So 20 upon 100 into 125. So here we will do the calculation. It is 25. Next is 15% of 540. So 15 upon 100 into 540. So we will find out this value. It is 81. So we will see some examples based on the population. So here the population of the city according to 1971 was 84,500, and it increased to 1,11,200 in 1981. Then find the percentage change in the population. So here first of all we will find the increase in this population, whatever is given in 1971 and 1981. So the difference or the increase is 26,700. So here for 84,500 the increase is 26,700. So we have to find the percentage change. So we'll assume for 100 what is the increase, that is x. Okay. So here we'll find out here 84,500 into x. Okay, simply we do the calculation, like 84,000 into x is equals to 100 into 26,700. So here if we will do the calculations, here we will get the answer as 31.5. So the percentage increase in the population is 31.5. So next example is a salesman gets 5% commission in his sale. If we get commission rupees 870 in a month, find his sales in that month. So let us begin. Suppose for sales 100 the commission is 5, because 5% commission is given. So for 100 rupees the commission is 5. Then we'll assume that for sales rupees x the commission is 870. So here again we'll do the calculation just like cross multiplication. Here 5x is equals to 100 into 870. Okay. So here x is equals to 17,400. So here the sales in that month is 17,400. So here simply we can find out the value which is the sales in that month. Next is an article is sold at 25% profit. Find the ratio of the cost price to the selling price. So here let the cost price be 100. So here by the formula, here profit we can find it is sold at 25% profit. So here 25 upon 100 into 100, that is profit is 25 rupees. And how we can find the selling price? Selling price is cost price plus profit. So here cost price is 100 and profit is 25. So selling price is 125. So here we have to find the ratio of the cost price and selling price. So here cost price we have assumed is 100 and the selling price is 125. So simply here the ratio we get is 4 is to 5. So the ratio of the cost price and selling price is 4 is to 5. So this is about the ratio, proportion and percentage.